In this video, we will discuss the different types of voids and the method to locate these voids in FCC structures. Now, what are voids? When the constituent particles gets close packed in different arrangements, empty space is formed between them, and this empty space is known as void. There are two types of voids: tetrahedral voids and octahedral voids. Now we'll see how this tetrahedral void is formed. Consider the close-packed arrangement of three atoms. Here, in between these three atoms, there is an empty space, and this empty space is known as a void. Now, if I place another atom over this void formed between these three atoms, when I place this atom over this empty space, that empty space is getting covered. Now, the shape of that empty space formed by these four atoms will be a tetrahedron shape. That is why the empty space formed there is known as a tetrahedral void. Now here, the tetrahedral void is formed by four atoms. Three atoms in one layer and one atom at the top. This tetrahedral void formation can be explained in a different way. Consider three atoms here. 1, 2, 3, and one atom at the top. Then the empty space formed will be at the center of all these. We are arranging it here. They all are touching each other. Okay. Then the empty space formed will be here, and this will be the tetrahedral void. Now we will see how octahedral voids are formed. Consider the arrangement of three atoms in one layer. A void is formed in between them. When you place the atoms like this, means the void formed on the first layer coincide with the second layer. Now this void, the new void, is formed by six atoms, so it is known as octahedral void. So now this particular void formed between these six atoms are known as octahedral voids, and these octahedral voids can be explained in a different way. Consider six atoms, four atoms in one plane, one at the top and one at the bottom, and these four atoms makes a square, and this one at the top and this atom at the bottom. Here the vacant space formed will be exactly at the center of this. See, these atoms are closely packed, they are touching each other, and this atom is placed at the top of that, and this is placed at the bottom. So the vacant space formed will be here, and this is known as octahedral void. So tetrahedral voids are formed by four atoms, and octahedral voids are formed by six atoms. Now we will see how to locate this octahedral and tetrahedral voids in FCC structure. We have learned in FCC there are four atoms are present in one unit cell. So in FCC, Z is equal to 4. If there are four atoms present in a unit cell, the number of tetrahedral voids formed will be 8, and number of octahedral voids formed will be 4. So in FCC, there will be 4 octahedral voids and 8 tetrahedral voids. Now we will see how to locate these 4 octahedral voids. Consider a face-centered unit cell. So in face-centered unit cell, atoms are present at the corners and the center of the faces. Now the atoms are present at the center of the faces. So this atom is at the top face, the center of the right side face, this one is left side and back side face, and this one is front, and here it is on the bottom face. Here you can see that these four atoms present in the center of these faces makes a square there, and this atom is below that, and this is above. So one vacant space or void is formed here, and this void is formed exactly at the center of the unit cell. So we have located one octahedral void. You can see that this void is surrounded by 6 atoms. One atom at the bottom, center of the bottom face, and one at the top, and 4 atoms on the center of 4 sides. So the center of the unit cell is one of the octahedral void. So we can write here, out of these 4 octahedral voids, one octahedral void at body center. Now there are 3 more octahedral voids are present. Consider another FCC unit cell. Okay, this is one cube, and atoms are present at all the corners and center of the faces. You consider one atom here at the corner, and another atom here, and one atom at the center of this right side face, and the atom present at the center of the bottom face. Now we need to consider another unit cell which is present just below this particular unit cell. Now we can see that there are 2 unit cells, right? So this is first unit cell. We started the explanation with that, and this is one is the second unit cell. Consider one of the atom present at the center of this face. Okay. Now we need one more unit cell which is placed right to this second unit cell, and now we have a third unit cell, and here we consider the atom which is present at the top face. Okay, now we can see that we have 6 atoms there, right? Now these 4 atoms are making a square there, and this atom is at the bottom, and this is a void. So you are getting a void exactly at the center of these 6 atoms, and this one is another octahedral void. So this octahedral void is formed at the center of an edge. Okay, so this octahedral void is formed at the center of an edge. You know that edge is shared between 4 unit cells. So the void present on that center of that edge also is shared between 4 unit cells. So only 1/4 of one void present at the center of the edge is actually belongs to one of the unit cells. So like this, all these edges are having one void at the center. So you can see that total number of voids, octahedral voids at the center of the edge. Center of the edges is equal to total 12 edges are there. From one edge center, 1/4 of the void belongs to one unit cell. So there will be total 3 voids. So 3 voids from the center of the edge. So here you can write one octahedral void at the body center and 3 octahedral voids, octahedral void at the center of the edge or edge center. So total 4. So 4 octahedral voids are there. One is at the center of the unit cell, and 3 are there at the center of the edges. Now we'll see where we can find these tetrahedral voids. And we know that in FCC, atoms are present at the corners and the center of the faces. Here we consider the atom present at this corner and the center of this face, and center of this face, and center of the left side face. So one corner atom and 3 face centered atoms. Here you can see that there are 4 atoms, and at the center of this atom there is a void. So the void will be formed here, exactly here, and this void is known as a tetrahedral void. So one corner atom makes one tetrahedral void. So there are total 8 corners. Corner atom creates one tetrahedral void. So total 8 corners are there in the cubic system. So total 8 corners create 8 tetrahedral voids. Hope you have learned how to locate the tetrahedral and octahedral voids in an FCC system. Thank you.